Well, up next in our little introductory series that we have going here to get the year started, I want to talk to you some about what dimensions are. Because interestingly enough, I think one of the things that you may have experienced in another class or that we jump into sometimes is dimensional analysis. So, dimensional analysis. And if you guys think about it, that's one of those things that strikes fear in the hearts of some students, because dimensional analysis is where we take things like, well, we say something's traveling 27 meters per second, and then we want to change that to miles per hour. And so we have to do these things where we multiply by these unit factors to get an answer that's in miles per hour. But if you think about these problems that we work, if you really think about what your science teachers have told you in the past, or what I'm going to tell you as we move forward, is that I'm less concerned about the numbers when we do dimensional analysis, at least in the beginning, as I am about these units that we deal with. Because if we want to change seconds into hours, well, we have to say, well, there's so many seconds in a minute, and then there's so many minutes in an hour, and so there's 60 seconds in 1 minute, and then there's 60 minutes in 1 hour. And as we take care of these units, then we end up with the dimension that we wanted. So what are we analyzing when we do this sort of math? Which this video is not to teach you dimensional analysis, but for you to understand that when we talk about dimensional analysis, we are analyzing dimensions. Well, so leads us back to the original question, just what are dimensions? Well, dimensions are just those things that we can measure, and I think it sometimes really surprises people that all of the things that we study in physics, just you name the unit and the thing that we're studying, you can boil it all down to some relationship between 7 fundamental dimensions, and I want to list those for you. The first one is length, just simply measuring the length of something. Mass, you can recognize that as being pretty fundamental. Time, how long something took. Electric current, and the unit for electric current is the ampere. That's less obvious to some people, but when we get into electricity and magnetism in the spring, it'll make more sense. Temperature, how hot or cold something is, and the units are important, but we'll get to that. How much of something that we have. And we're talking about here in terms of moles, how many atoms or molecules are of a particular substance, and maybe in what combinations. And then one that's not as obvious to folks, but the luminous intensity of something. We think about colors and brightness of things, and so we have to think about its luminosity. So these are the 7 fundamental dimensions that we deal with in physics. All right, so if we take a look at this neat little graphic, this is what I want to leave you with. We start off, and if you notice here on the left, these are those 7 fundamental dimensions that we just talked about. And what we're going to do through the year in physics is move across, and essentially we're going to here. Oh, wait a minute! I made a boo-boo. So let me back up here. We're going to take these fundamental dimensions, and then as we move across, I want you to see the sorts of dimensions that they turn into. So let's just look at this little block right here, and I just want to give you a couple of examples here. So things like volume. Well, if you can see there, if we look in there closely, volume is length times length times length, length times width times height. So those 3 lengths go to give us volume. We'll talk about velocity. Well, that's meters per second. So the dimension of length compared to time. And then later on, acceleration is velocity, change the rate of change of velocity. But if you look at the units, it's length per second per second. And then we can move on. There'll be things that we'll move on into just as the year goes by, you see newtons there, those fundamental units of kilogram meter per second square. And I can go on, but the point I'm trying to make and what's relevant for this introduction is simply that all of these complicated things that we study later in the year, or that seem complicated, we can trace back to 7 fundamental dimensions that we measure. And so my goal in telling you this is hopefully to show you that this is not something to be intimidated about, because we're going to start simply with the fundamental dimensions and we're going to progress through to more complicated units and relationships, but we can always work backwards to see just those fundamental dimensions that are involved in a complex relationship later on. I hope this alleviates some of your fears of the mathematics and helps you understand part of how we approach problems in physics.